Good afternoon, Algebra 2 Trig Honor students. So it's me again, Mr. Chen. And again, my purpose of doing the YouTube channel for all the lessons for Algebra 2 and Trig, so just want to help all the students out. So in case that they're missing something from the distant learning, or things that you guys want to refresh your memory, or things that you want to review for the tests. So I really want to help out all the students, not just the student that I've been teaching currently, but all the student that who search for things that they were missing from the YouTube channel. So you guys are welcome to give me any comment. Please, if you do like the channel, so I really want you to subscribe to the channel and please click the bell. So in case that you're wondering about the new videos coming up. So I really appreciate it. So the one that I would like to talk about today, so since my classes, they're all done with Algebra 2. So I want to start it with trigonometry. So the first thing that I would like to get started off is the SOHCAHTOA. So that's something you guys probably already being exposed from geometry honors or regular geometry from last year. Okay, so now we'll take a look at that. So we do know that SOHCAHTOA, that means it's considered the one involved with sine, cosine, and tangent. So let's say that we do have a right triangle, so the little square symbol is supposed to be a little bit down the bottom here. So anytime that you see the little square symbol here, so that means it's considered a right triangle. Okay, so we do know triangles. Okay, so this one's supposed to be A, B, and C. So where B, it's the right triangle. And then A right here, so that's the vertex angle. So C should be the one down the bottom. But this one is being labeled differently. So let me just put in the size. So normally the size being categorized with the lowercase letter. So let me change that. So this one's supposed to be A, B, and C. So segment A, segment B, segment C. And then M, this one is called the base angle. Okay, so this one here, it's called the base angle. So which side, A, B, or C, are opposites to... Okay, so it doesn't say that looking across to the base angle. Well, it depends on which base angle that we're talking about. So let's say that if the base angle is M, so that means the opposite side would be what? Segment A. And then which side it's next to, adjacent to you. Okay, so which side is adjacent to that opposite right here, to that A. So the side which is opposite, so then that would be B. Okay, and then which is the hypotenuse? Hypotenuse, it's always considered the longest leg of the right triangle. So C would be the longest side of this right triangle. Again, we're using M as the base angle, so the one that's crossed to this base angle, the side, which is what? Segment A. And which side is right next to the adjacent? So right next to it, adjacent, that means right next to it. So segment B. Well, you might be saying that C is also right next to it. It is, but that one is called the hypotenuse, so which is the longest leg. Okay, so now let's take a look at that, the example. So now you're standing at angle K. So label opposite, adjacent, and hypotenuse. So opposite, which is facing across that angle K. Adjacent, that means it's right next to the base angle. So adjacent, so then that would be considered this one here. And then hypotenuse. So as you can see that I just used the abbreviation letters. Okay, so hypotenuse, opposite, adjacent. And now for the other one here, so K is right here. That's the base angle. So the one which is adjacent to it, which is this one. And opposite, the one facing across, which is this one. And then hypotenuse, which is this one here. Okay, excuse me for a second. Let me keep the door closed. Okay, so now to look at that, the other one down the bottom of this page. So now you do have all those basic structure of the right triangle. So we do have the base angle, adjacent, opposite, hypotenuse. So now the next one, we want to go through the concept again for SOHCAHTOA. So SOHCAHTOA, we do know that sine of angle K, that's considered opposite over hypotenuse. Okay, cosine of angle K, that's considered adjacent over hypotenuse. Tangent, so that's just abbreviations, opposite over adjacent. So again, the acronym. Okay, so for all this, so this one is just the easy way to recognize all those special formula. So sine of the angle, it's always considered opposite over hypotenuse. And then cosine of that base angle K, it's always considered adjacent over hypotenuse. And then tangent of that same base angle, it's opposite over adjacent. So basically this one will give you the ratios, the trigonometric ratios of all those operations. Okay? So now, what about for CHOSHACAO? CHOSHACAO is just the other acronym. So this one is just the other way to recognize the reciprocals of all those trig ratio. So let's say that you want to find out the reciprocals of sine. So the reciprocals of sine, then that would be considered cosecant. So cosecant of the base angle, then that would be considered hypotenuse, not opposite, but hypotenuse over opposite. So basically you just need to reverse that, the order of opposite and hypotenuse. And then for the reciprocals of cosine, then that would be considered secant of that base angle. So this one, we're using that the reciprocals of the ratio, which is hypotenuse over adjacent. And then cotangent, so cotangent of the angle would be considered the reciprocals of tangent, which is adjacent over opposite. So the 6 trig functions of all using O, A, and H of a right triangle. So that means using that opposite, adjacent, and hypotenuse. So now, let's take a look at that, some of the example here. So given the following triangles, find the remaining 5 trig functions. So first label the opposite, adjacent, and hypotenuse. So sides of O, A, and H on the triangle. And some of the functions are already done for you. Okay, so this one is, some of those are given already. So we started with angle R. So we're using that angle R as the base angle. So obviously adjacent would be what? 3. Because that's right next to it, or you can obviously say that capital A. And then the one facing across, so 4 would be the opposite. So then that would be what? O, capital O. And then 5, which is the hypotenuse, then that would be H. So normally I like to abbreviate it with that ADJ, adjacent, opposite, OPP, and then hypotenuse, HYP. Okay? So now, using the ratios, so cosine of R obviously is what? Adjacent over hypotenuse. So plugging a number. Okay, so let's just start with the formula first. So it's going to be A over H. So 3/5. And then tangent of R, so opposite over adjacent. So O over A. So which is 4 over 3. And then cosecant of R, which is hypotenuse over opposite. So then that will be considered 5 over 4. Again, the slash, that means it's just a fractional bar. And then secant of R. So secant of R is hypotenuse over adjacent. So H over A. So which is 5 over 3. And then cotangent of R, which is adjacent over opposite. So then that would be considered 3 over 4. And then for the other examples, so you can do the exact same thing. So angle K, that's the base angle. So that means 5, which is the adjacent. And then 12 would be the opposite. And then 13 would be the hypotenuse. So cosine of K, so similar to the previous one. So adjacent over hypotenuse. So 5 over 13. Okay, so you can just say that adjacent over hypotenuse. Or A over H. So 5 over 13. So just wanted to get used with the ratios. So the formula for the trig ratios. So tangent of K, which is opposite over adjacent. So then that would be 12 over 5. And then cosecant of K, hypotenuse over opposite. 13 over 12. Secant of K. So secant of K would be hypotenuse over adjacent. So then that would be 13 over 5. And then cotangent of K, then that would be adjacent over opposite. All right. Okay, so now let's see what else. And the rest of the example, they're quite similar. So this one, instead of using the angle, so this one is called theta. So the Greek letter, theta. So theta is the base angle. So we want to find out, evaluate the 6 trigonometric functions, so sine of theta. So the one that's missing here is the hypotenuse. So since we do know that's a right triangle, so we can find out the hypotenuse by using the Pythagorean theorem. So then that would be considered a squared plus b squared equals c squared. So we'll just consider a squared plus 15 squared. So that equals c squared. So 64 plus 225. So that equals c squared. So this one, combine them. So then that would be considered 289. And square root of 289, which is, not quite sure what that is. You can always use the Google calculator. 17. It's a perfect square number. Whoops. So 17 right here, which is the hypotenuse. So sine of theta, then that'll be considered 8 over, well, let's just label the segment. So this one is what? Opposite, adjacent, and 17, obviously, the hypotenuse that we just found. So using the formula that we identified earlier, so sine, which is opposite over hypotenuse, so it's 8 over 17. Cosecant, that's just the reciprocals of sine, which is 17 over 8. Cosine of theta, adjacent over hypotenuse, so 15 over 17. Secant of theta, hypotenuse over adjacent, so 17 over 15. Tangent of theta, opposite over adjacent, so 8 over 15. Cotangent, reciprocals of tangent, so which is 15 over 8. So once you get used to it, there's no need to write down the formulas again. And the other one is quite similar, so this one you guys can figure out what that is. Okay, so that would be the day 1 lesson. So we'll just stop here. So once again, if you guys do like the channel, I really want you to subscribe to the channel because there are more upcoming video regarding trigonometry. So besides like ratios, it's going to be a lot of things involved with trig. So things such as graphing, identities, all those type of essential curriculum that I need to cover in class. Okay, so, and thank you for the subscription. So I'll see you guys next time. You guys have a great one.